All right, so on 26, if I sketch the picture, they have two sides and an angle. So the angle they have is 21 degrees. The side opposite that angle is 17, and then the other side, either of the other sides here, I'll use this one, is 32. So that means the angle opposite that, again, this is side C, this is side B. So the angles opposite are the uppercase letters that correspond to those, which means this has to be point A. All right, so which pattern of information is provided here? Two sides, is the angle included between the two sides, or is it opposite one of the sides? It's opposite, right? So we're looking at an SSA pattern. Okay, SSA is the pattern that you may have one solution or you may have two. Do you remember the rule that determines whether there's one or two? The side opposite the given angle, if it's smaller than the other given side, you're going to have two. So in this particular case, we're looking at two different solutions. Now, you don't have to actually go through and determine this because I specifically give you answer spaces for both of them. All right, so let's go through and we'll find this example, the one that's drawn more similar to this picture. All right, so we have one set ratio. Right? Anytime you use law of sines, you need to have a set ratio, a given side and a given angle. And we have ours. So which angle can we find first in this? Okay, so here's the three pieces of information we need to find. Which of these angles, A or C, can we find first? C, right? Because here, if we take the sine of C, again, I'll always start my law of sines with the unknown in the numerator. So sine of C over the side opposite that is equal to that known ratio, that set ratio. So the sine of 21 degrees over the opposite side, 17. Okay, and we're just going to use the solve feature of our calculators to figure this out. Now again, remember, when we're solving for an unknown angle, okay, we can't, the calculators won't allow you to solve inside of a trig ratio. You have to basically let our variable be the entire sine ratio, not just C, but the sine of C. So we're going to let that substitute in for the sine of C, and we're going to solve for that ratio. So when I type this in, the F2 algebra tab, and I enter my equation, x divided by 32 is equal to the sine of 21. I'll put a decimal in here so my answer is displayed in decimal form over 17. And I want to solve for x. Now, what this is giving me is it's giving me the sine ratio for angle C, which should be a value between what? Sine and cosine ratios always fall between what two measures? -1 and 1. So when I hit enter, I expect to see a number between -1 and 1. If I get a number that falls outside of that, then I know I did something wrong. So I get 0.675. That's consistent. It's within the realm of what I was expecting. That is the sine of my angle. So if I want to actually find what that angle is, which I do, what do I have to do with this ratio? Take the inverse sine of that ratio. Okay, so now if I take the inverse sine, so green diamond y, of this measure, and again, I can delete the x here. Let me show you a different way that you can approach this. You can approach this using the with key to save the time of having to go in and delete the x equals. Because if you type in inverse sine of x, close off the parentheses and then use the with key, and then highlight your x equals. Does everybody see how that's going to substitute that value in for me? So if you want, you can do this instead of going in and deleting the x equals part. So I hit enter and I get my angle measure for C, which is 42.42 degrees. All right, and then what do I need to do in order to solve for angle A? I know that the sum of these three angles here, A, B, and C, has to equal 180. So if I subtract the two angles I have, which is 21 and this 42.42, I get what's left, 116.58. And then my final step here is to solve for the side opposite, angle A, which is lowercase a. And when I solve for that, I'm going to use the law of sines once again, but this time my A, my side, is in the numerator. So I'm going to start with A over the sine of the angle opposite it, is the angle that we just found, 116.58, and set that equal to our known ratio. Now, as I write this known ratio, I flip it because I'm starting with the sides on top. I'm going to use the solve feature. And here, since my unknown is not embedded within a trig ratio, the calculator will give that to you. So I'm just going to substitute the x in to make it easier to type. But I have x over the sine of this angle that I just found. And that has to equal the ratio of 17 divided by the sine of 21. And we're solving for x, which again was replacing that side length A. And here when I calculate this, oops. Hold on. No, winds up being the same, 42.42. But this time that is an actual length and not an angle measure. All right, so I found one of my cases. So there's a second possible triangle that's formed here, and we can visually identify that triangle by swinging this point C over. So here's C2. And we create this smaller triangle inside here, and so I'll call this A2. B still stays the same, so if I want to find the other angle measures and the other side length, which is right here, A2, I can go back in. And now my calculations are different. I don't have to go through all of these calculations again because this triangle right here that I'm using as my reference is an isosceles triangle. So what do I know this angle measure has to be? Opposite angles, or angles opposite equal sides of a triangle are equal, so this is going to be that 42.42 degrees. And so the angle that I'm looking for, this C2 value that's inside here, is the supplement or the linear pair to this angle. So if I take 180, and I subtract that measure, so I'm going to go all the way up here. Here's was my angle measure calculation, and hit enter. I get my new angle of 137.58. So there's my new angle C. And then so my angle A can be found by taking, just like I did up here to find angle A, take 180, subtract the known angle B, 21 degrees, and subtract the angle I just found C, this 137 degrees, and I get my measure of 21.42. And my final step is to, again, calculate for my side A. I'm going to use the law of sines, A over the sine of the angle opposite it, which we found now to be 21.42. That's still going to equal my set ratio, 17 over sine of 21. Use my solve feature. And again, just for the ease of calculating, I'm going to use x instead of the A2 value. If I hit the F2 algebra tab, type my equation in, x over the sine of this 21 degree angle. Set that equal to my known ratio, 17 over the sine of 21. Close it off and solve for x. And when I do, I get my measure of 17.33 approximately. So these would be my two different scenarios.